My name is Kojo Idrissa, and the talk I'm giving is a junior developer's guide to software engineering. You can see a few basic things about me. I am myself a junior developer, but I'm someone who changed careers. I used to be a university instructor and an accountant before I did that, which is one of the reasons I'm giving this talk. But I also do a few other things. So we're here at Pi Gotham now at this conference. I'm also one of the organizers for DjangoCon, and so that's a week from Sunday in San Diego. I'm also the DEFNA North American ambassador, and what that means is I spend a lot of time traveling around North America, letting people know about DEFNA, which is Django Events Foundation North America. That's the nonprofit that puts on DjangoCon, but DEFNA also does work to try to support other Django-related activities in North America. So there are grants that are available. If you want more information about that, you can check out DEFNATO on Twitter, or you can follow the hashtag NorAmGT on Twitter, because that's me wandering around North America and doing interesting things. But that's not what this talk is about. So what is the talk about? The talk is about junior developers and helping them become familiar with software engineering. But it starts with this question of coding and why are you coding and what are you planning to do? So we have people who are learning to code, but everyone has different reasons. I'm going to focus on two general categories of why people might learn to code that I've identified. So you have two basic styles of coding that I've identified. And again, these aren't necessarily, you won't find these in a computer science textbook per se, but these are the two styles of coding I've identified. I split them into programming versus software engineering. Programming, as you can see, it's someone who is writing code, maybe on their own. The person who's going to be running the code is going to be the actual author of that code, and that code doesn't need to be super robust because the author is the one who's running the code. So if something goes wrong, they have a capacity to fix it. On the other hand, you have software engineering. That software that is built in teams instead of by individuals, the software is intended to be run by other people, not the authors. And then as a result, that software needs to be more robust because the people who are using it don't often have the capacity to fix it. Even if it's open source software, it's not intended to be tinkered with, it's intended to just function. And so this talk is going to focus more on software engineering. But I have this interjection here with real coders in scare quotes. So the idea is this separation is not intended to say, oh, one style of coding is the real style and the other one is a faker for amateurs. They're just two different valid paths. So if you write code, your code runs, you're a real coder. Congratulations, your decoder ring is in the mail. We look forward to seeing you at the meetings, that sort of thing. But there is a real difference in coding styles, and depending on what it is you're trying to do, you might want to focus on one more than the other. So this talk is focusing more on software engineering, which is usually the approach that people are taking if they're trying to find a job as a developer, if they're trying to change careers. And so that's the issue here. You've got people who are changing careers, they're looking for these junior developer jobs or some sort of coding internship, but there's no real definition for junior developer. Like what does junior developer mean? It often just means someone who knows less stuff than I do. And so people often have the question, especially people who are changing careers, well, when am I ready? How do I know when I'm ready to get a job as a junior developer? And the approach that they often take is to more programming, just to focus on more code. Since there's not a real definition for a junior developer skill set, they tend to try to focus on learning more of the language that they're learning, but that's like trying to make yourself a better author by memorizing a dictionary. It doesn't work. Just like more words won't turn you into a great investigative journalist. And so the question of how much Python do I need to know before I can get a junior developer job, that's not really the best question to ask. You need to focus on some other things. And that's what this talk is focusing on. That's the primary issue. The secondary issue is for people who are in a position to maybe mentor new developers or junior developers, the question of, okay, we've got a new developer or a junior developer who's joined our team, what sort of things do I need to focus on to make sure that they're prepared? And so that's sort of a secondary focus of this talk. So what am I going to talk about here specifically? Here are the things that I'm looking at as far as points of interest for junior developers, and I'm focusing on these things because these are things that I think, even if you are new to programming, if you're very new to programming, you can start to learn these skills, and these are the skills that will help you as a software engineer. I've met people who think, oh, well, I'm not an advanced enough programmer or a developer yet to do these things. Well, you can really start doing a lot of these things right up front. So version control, documentation, and testing are what I'll be focusing on mostly. Dependency management, the items that are in blue, can you all see the blue from out here? Hopefully, yes, no? Yeah, no, not really. So in theory, the bottom two bullet points are in blue. Dependency management and deployment and development environment, those are things that I'm going to focus on in a little less detail, just because of time constraints. So version control. Why, as a software engineer, do you need to learn version control, even as a new software engineer or someone early in their career? One, it protects you from yourself. And as far as version control goes, I'm going to be focusing mostly on Git because that's sort of the dominant package, but there are there's other software for version control. But using version control helps you protect yourself from mistakes that you might make. It also makes it easier for you to try new things and to learn new things. But then the third thing is it's very important for learning to work on a team. And so if you're using Git or GitHub, which we'll talk about a little bit later, that's something that gets used if you're working in a team that's building software. And again, if you're focusing on software engineering, most commercial software or open source software is built in teams. It's not built by individuals. So that's the why of version control. That's why it's important for junior developers to start to learn as soon as possible. So when is the next thing? It's like, so when do I start using it? Again, people feel like I'm not an advanced enough developer. I need to wait until I'm doing all the advanced wicked codes. Well, no. Once you get to a point where you've got more code than you feel like retyping, use version control because it's your friend who can help you. Or when you've got stuff that you're worried about breaking. So once you get to, I've used sort of like a 10-line mark as an arbitrary mark for how much code you want to retype, because 8 or 9 lines of code, okay, fine, you retype that. Once you get to 10 or more, it becomes a hassle to have to type it over and over and over again. And once you get to a point where you've got some code that works and you're like, okay, I want to add a new thing, oh, it might break. That's the signal that you need version control. And specifically, we need to start learning about branching and merging, because if you have your software in some sort of version control and then you create a branch, you can try all sorts of new things. And if it breaks, that's fine. You can just go back to your master branch. So how do you learn about version control as a newer software engineer or a newer developer? The first thing is you can learn to use Git by yourself. And a lot of people conflate Git and GitHub, but they are not the same thing. They're definitely related, but they're not the same thing. So you can start to learn to use Git by yourself. And doing that on your own projects by yourself is helpful because it helps you develop this practice of making these, what I call atomic commits. And so you don't want to write a huge amount of code and then commit it, and then write a huge amount of code and then commit it, because if something breaks somewhere in there, it's hard to isolate it. And so, but again, especially as a newer developer, that's not really a rhythm that you may be in. And so starting to use version control early on in your code learning process can be beneficial because it helps you learn to develop that rhythm for these atomic commits. And then again, if you go back and break something, which is more likely when you're in the earlier stages, it's easier to isolate where that problem is. It also makes it easier for people to review your code or give you code reviews, especially if you're working in a team. And then if you are doing these small commits and then you start using the branching features that Git offers you, having these smaller commits makes it easier to isolate when and where you want to branch out and when and where you want to merge back in. It avoids merge conflicts. And again, you can use Git by yourself, and then you can use GitHub by yourself and just learn how to work those things, work with those two tools and do branches and merges and that sort of thing. And so if you are then looking for a job to work with a software development team, you're already ahead of the curve. So these are things that you can all do. In this version of the talk, I've done a longer version of this talk. In this version, I don't really have time to go into a practical example, but we can talk about that later if you'd like. And so then the how of version control. So how do you learn about, I've said all these wonderful things, you should learn this, you should learn that. Well, how do you go about doing that? There's a book called ProGit, and it is an excellent reference book. It also has the benefit of being free. So if you just Google ProGit book, you will find that book online, and it is free of charge. And the first 3 chapters of that book will teach you about 80% of what you need to know to use Git effectively on a day-to-day basis. Git is very large, and there are a lot of features and details. So there's a lot more you could learn, but most of what you'll use on a day-to-day basis, about 80% of that is going to be in those first 3 chapters. And then each chapter is broken into small sections, so it's very easily digestible. So, and I might be biased, this is how I learned Git. Well, one of the ways I learned Git. But this is sort of the how. How do you get started? So even if you're new to development, you can start using this from really from day one. So the next thing we talk about here is documentation. And so here I'm talking about documentation inside your code, not documentation about the code. So not like read the docs type of thing, but documentation that you put inside your code. And the reasons that you want to do that is because, one, it helps you sort of refine your thinking about, okay, what am I trying to do here? What am I trying to get done? How am I trying to do it? It also forces you to think about your code before you write it, or you give it more thought while you're writing it. And the reality is, as clever as we all like to think we are, if you work on some code and then you go away from it for a couple of weeks, when you come back, maybe you remember what you were doing, maybe you won't. So please be kind to your future self and leave some notes there so that when future you comes back, it's helpful. Another interesting thing is when you're working with teams, again, if you're writing code and maybe you want someone else on your team to review it, or even if you are having friends help you learn to code, having some documentation there can help those people help you. So I've got another interjection here about self-documenting code. You might have heard this term. I see some people laughing. You might have heard this term. Good code is self-documenting. So that is one of those things where there's a kernel of truth there, but it's not entirely true. So good code is self-documenting if your variables, your functions, your classes, all that sort of thing, if they all have excellent names, and those names tell you exactly what those things do, and maybe even how they do it. So maybe you have a function that's called average, or a function that's called weighted average, so you know what it's doing and how, that sort of thing. And so if all those things fall into place, it's self-documented code. Also, if the person reading the code and the documentation understands it perfectly, then it's self-documenting code. The reality is naming is hard. And to the point where there are entire talks just about the difficulties of naming things. And so if you are new to software development and trying to improve your skills, naming is a hard thing, and you only get better at it by doing it. And so having documentation is important. So this self-documenting code thing, it can be true theoretically, but err on the side of having more documentation than less. But starting to think about these sorts of things now or early in your programming career, your programming life, will make you better at them. So when do you document? Some good times to document are if you're writing code that's using a technique that is new to you. And so that way you can remind yourself, okay, why did I use this? Why did I use a list here instead of a tuple? Why did I use this function instead of that function? And so those are just sort of inline comments you might want to put in your code. But also if you get to a point where you start, well, not if, when you get to a point when you start to write functions, you want to put doc strings in those functions because functions are one of the first places that your code becomes less obvious. Because now, like, you've written a function and you're just calling this thing like Kojo _ awesome. Well, yes, that's true, but what does that function do? And so, you don't really know what's going on there. So putting a doc string in that function can help you understand, okay, what did I do here? Why did I do it? Why did I make these decisions? And then if you use the Python help function, that doc string ends up becoming the help. So help you. This is important. Please write that down. And so how do you go about documenting things? Again, I've talked about putting inline documentation or inline comments in your code, but I would say once you start to write functions or methods, if you're doing object-oriented programming, the functions that are attached to a class are known as methods. At a minimum, for your functions, you want to have documentation that tells you what the function does, what inputs the function takes, including the data types, and then what output the function provides, again, including the data types, because those things can be very important in debugging something that's gone wrong. So that is very important. So that's sort of the how. Now, testing and TDD, I'm going to focus more on testing than TDD. Why do you want to test? There are so many reasons, and this is a big topic that I don't have the time to go into in tremendous detail, but I do want to lay out sort of a flow that motivates the testing approach. So here we've got the big picture of testing. So when we talk about testing, really we are talking, when people tell you testing is important, what they're really saying and what they don't always explain in detail is that you write tests so that you can have automated tests. You want automated tests because you want those tests to run every time something is added to your code. When we talked before about using Git to branch and then to merge things back in, that merging process is called integration. In an optimal situation, every time someone adds new code, you want that code to be integrated or to be merged back into the main code base, but you want to make sure it's not breaking anything. And so you want your tests to run, and if you've got, so that's continuous integration. If you have continuous integration, you can then have continuous delivery, which means every time someone adds new code, you are ready to ship that code. You don't have to, but you can. From continuous delivery, you can go to continuous deployment, which means every time someone adds new code and all your automated tests run and they pass, you can then just, the code just is out there live. So, but none of that happens without having tests. So this is why you need to start writing tests. Why? Having these tests, again, it protects you, and I'm focusing here on two types of tests. There are a lot of different types of tests. Here I'm focusing mostly on unit tests and regression tests. Unit tests focus on a small piece of code. Regression tests focus on finding a bug and then fixing it and then writing a test to make sure that fix remains in place. And so that's what those two things do. So those are the tests, those are some of the best tests to get started with. When should you start writing tests? As soon as possible, because testing is an art and a science. You get better at it by doing it. How do you go about testing? So Python has doc test and the unit test modules built in. Those are excellent places to start if you are a little worried about installing new things. PyTest is a third-party module that's becoming really one of the most popular test running suites. And so that's another good place to get started. So here we've got dependency management and deployment. I'm going to go through these quickly. Dependency management is about having all the pieces that you need for your software to run. So virtual environments do that. They provide an environment where all the different libraries that you need are in place. Containers do the same thing, but they also help with being able to deploy your software. Virtual machines are similar, but on a slightly larger scale. In addition, you want to make sure you're familiar with your development environment. So are you familiar with the command line if that's where you'll be developing? Do you know a shell language like Bash to help you work in that environment? Are you familiar with the terminal multiplexer? That's something that's especially useful for web developers. Here, this is a thing for engineering managers, dev leads, and other people who are hiring developers. If you're hiring new developers, try to keep some of these things in mind because it is easier to take a junior developer and get them to where you need to be than to try to find an experienced developer. It's also going to be a lot less expensive. And you can't compete financially with the Facebooks and the Googles of the world. So that's all that I've got. This repo is where the slides will be later. They're not there quite yet, but that's where they will be a little bit later. And if you have any questions, I am Transition on Twitter, and you can read my sometimes updated blog. And thank you for your time.